what I'm going to do is, this is the talk I'm giving you tonight. Gina told me today, she said, make sure you put some pictures of owls in there. And so, because, it's the talk. I was, asked to be the keynote speaker for the World Owl Conference that was just held. So we had, 150 people from 13 different countries all give talks. And so it was more of a little bit of a technical talk with less owl pictures and more graphs. But I've been pretty good over the years of balancing that. So I looked at it today and Gene said, put a few more owl pictures in, please. So I'm going to try to balance some research results over the years, just some highlights of our long-eared owl research in its 37th year with some nice photos. As I say at the talks, sometimes we forget why we got into wildlife research because we get so kind of directed towards research, publishing papers, this, and that we forget the reasons that we were the boys and girls as we were attracted to this. And it was kind of cool. It made us feel good. And I try to remind the people at professional meetings when they get so data-driven that they're forgetting why we got into it. And so I try to sprinkle that in anymore. And I think it's been pretty well received at the professional meetings. And this is my pointer. Because these things here don't take like laser pointers. So I had to go out and forage to get this about an hour ago. And as you can probably see here, I guess the big thing is we have long-term studies. So I'm going to preface this with what I preface everything with. And I know the message gets old, but it's the only way to make sure that you remember it. Is years ago when I was at the University of Montana, I went back, I was in my 20s, I worked a little bit, but I was still, impressionable student in my 20s, but it didn't take me long to learn that even if I was lucky enough to get a job in wildlife, the probability of being out in the field was pretty slim. The traditional homes of research are the feds, state, and the U, and again, not to hurt anybody's feelings, but my profs didn't go out that much, and then the agency biologists that I work with, they didn't go out that much, and it wasn't my vision of what I wanted to be. I wanted to be a field researcher, like the construction worker, wildlife research. And so as things went on, and I worked for this group and that group and all that, and was following all the rules. At one point I said, I want to be a field researcher. I don't want to end up sitting around. So anyhow, started the Owl Institute. Everybody made fun of it, and still do, some people. And but now we're probably the leading group in the world on owl research and all that. So, and I'm just going to kind of go over it. So there's a whole bunch of studies here, but we're going to talk about the long-eared owl one into its 37th year. It's a little bit different than the other studies because it's a year-round study, mostly conducted in western Montana. So let's see if this works. And I'm going to try to I'm going to talk fast, it's hot, and I'll buzz through some, of the data just to give you the summary sentences and all that stuff there. So anyway, that's what a long-eared owl looks like. Hey, should we cut a few lights, do you think? Or what do you guys, why don't you do that? Anyway, this is just a distribution. These things are pretty general. You can get them off the internet. But, the permanent residency and non-breeding. But it just gives you a general idea of how widespread long-eared owls are. Okay, so many years ago, I was asked to participate in the Christmas bird count in Missoula. And it was when I first arrived here. And so I said, oh, yeah, sure, I'll do that. And they said, well, there's a place out west of town that is a big ranch out there that nobody's ever been on. I said, oh, I'll drive down there and ask the rancher. And so I drove down and, pulled up, and the dogs bit my ankles and all that stuff. And the guy comes out and he goes, can I help you? And I said, yeah, with the Audubon, we want to do a bird count here. And he said, you want to go hunting? I go, no, we want to count birds. And he said, you want to count birds? And I said, yeah. And then, basically they went back and forth. He laughed a little bit. He goes, that sounds kind of harmless. Okay, so we did. And this was his ranch here. It's kind of broken up now. And this was the type of habitat. So when we went in there and looked around and started counting all the birds we could find, we stumbled upon this. And as you can see here, this is a communal roost of long-eared owls, all right? And so, right away, I'm like, wow, that's pretty cool. And I had already had a little experience being from Massachusetts. We had long-eared owls in pine groves back there that people would kind of discover in the wintertime. So I was a little familiar with it and already had some thoughts about it. So I said, geez, I wonder if these guys are related. You know, are these family groups and all that stuff there? So that kind of jumped out right away. And that was like the initial question. All right, our winter communal roost, and a communal roost is, 2 or more. Are they family groups? So we went after that. And then, we started to go out and catch as many owls as possible. Just like, all right, we'll just catch them all. We'll see if we can figure this out. And it dawned on me that, well, there's more to it than just catching all the owls. And, how do we know what's going on? How do we know if they're family groups? And this was the wintertime. But we noticed right away that some of them were a little smaller and lighter colored, and some of them were a little larger and darker colored. And I thought, geez, I wonder if there's a difference between the sexes here. All right, so that popped up. So we had 2 simultaneous questions, Is there sexual color dimorphism between males and females? And are the winter communal roosts related individuals? So anyway, I had done some work on small mammals, and I, had used the Munsell color chart to score pelages of small mammals. And I said, maybe I can do this. So what we did, we caught all the birds we could in the wintertime, predicted their sex, just based on some knowledge here. And then we went to the breeding season, and we caught all the known sexed birds. So how we knew when we caught this bird that it was a female is that only females and owls develop a brood patch. So there's changes in estrogen and prolactin, and the feathers just fall out, and it creates the brood patch where she can incubate the eggs at about 100, 104 degrees or so. And males do not have that. So that's how we said positively, she's off the nest, she's got a brood patch female. The one roosting near the nest, doing nest defense, providing food, predicted male. All right, so we went from there. And then we noticed a few other things. We noticed that some of them on the wing coverts here were buffy colored and some were white colored, but it was kind of looking like it was sex specific. All right, and then we looked at the legs here, the tarsus. And so now we're piecing this together, just had an idea. And just to make a long story, so when you analyze it, we look at the underwings, we look at the legs, we look at the facial disc, and it's all, mathematically, all statistically significantly different. Does that really mean much other than that? And so then what we did is we went out and we looked at what we caught and predicted. So we caught 887, predicted them, the males, predicted the females, confirmed as breeders. And so anyway, long story short, in this time period, based on just plumage, all right, we have DNA and all that stuff, but based on just plumage traits that we were told at the time we started that no one can do that. And so I remember the guy who told me that too. And anyway, so we published a paper and you can do it. We can anyway. And anyway, it's pretty easy if you work on them. So basically, males are smaller, lighter colored, lighter in the face, the breast, the underwing coverts. Females are larger headed, more rusty colored, rusty in the breast, rusty in the other tail coverts and on the legs. And so we can use that now, and we're good enough now that if it flies by, we can say it's a male or a female, and then we can catch them and go from there. So anyway, that was kind of cool. Again, these are highlights. Well, each question goes into the next question, all right? And that's just, your brain's going crazy out there, and what about this? What about that? What about this? So the next thing I thought was, there's supposed to be 2 species of long-eared owls, subspecies, in the United States. But is that really true? And so maybe what we're seeing, those color differences that they had described in the older literature, I wonder if that was just the differences between the sexes. And then we looked at egg measurements. Anyway, so we just got a bunch of banding records, and if you look at it, it's all over the place. How can there be 2 subspecies when everybody's crossing from here to there and all that and breeding in different areas all the time? So we proposed that, and now people are starting to say, hey, maybe there is only 1 species of long-eared in the U.S., and those color differences we saw with some individual variation are really just the sexes. All right, and so then, again, and it just leads, one thing leads to another, another leads to another. So we said, well, we're going to have to monitor the nesting. It's not good enough just to say, oh, there's a bunch of nests, the population's doing well. You've got to figure out how they're doing. Are they reproducing? Are their children reproducing? So that leads into a whole other thing, is just looking at nests and monitoring nests and just, going in there, capturing the female, finding the male. Look at this camouflage color here, I mean, pretty cool stuff there. And that's another story of adaptations. And so capturing the birds, getting to know the male and the female, and then going in and monitoring. This is a little bright, I think. I can't tell from here, but you can see a couple of dead mice in here. And then you see the size differences, as most of you may or may not know, unlike ducks and chickens and geese and things of that sort, whose eggs hatch relatively, on the same day or relative synchrony. Owls hatch in the order laid, and they begin incubation, usually in the first or second egg. Can lay an egg every other day or every 3 days. It kind of depends on certain circumstances. And so they hatch in the order of which they're laid, so you get asynchronous growth, asynchronous hatching, versus all your chickens and pheasants hatch pretty much on the same day. So anyway, monitoring them, trying to get them, monitoring their growth. Yeah, pretty cool stuff here. And nice photos. This is it. I got to get some good photos in. And so we continue to monitor them. And you still have to know the chicks and all that stuff here and look at growth. So we thought it'd be interesting to look at their growth. And so you can see here, this is interesting. You may or may not know. You know how people always find an owl on the ground. They bring it in, or something like that. Well, many of these species, they leave their nests well before they can fly. All right, and so there's certain things, and we'll get to that a little later on, but most of their growth is right up in here, and they just grow tremendously right up until about 3 weeks of age is when they leave the nest, and then they kind of asymptote out here, and they slow down their growth, but they're putting on all this mass about a week before they're leaving the nest. Well, you think you would want to. If you're getting ready to go out on your own, in a sense, you can't fly yet, but you get out and you're in the branches, and you're still dependent on mom and dad for food and protection, but you got to get as much mass and as much fastest growth as you can to get out there and face the elements on your own. You can't crawl under your mother's armpits anymore. All right, so this is them. This is the asynchrony. This guy's getting to be about that right age at about 3 weeks or so. These photos look terrible from my angle. I don't know what they look like out there. Okay, all right, so then, another question came up. Why leave the nest at 3 weeks of age? And short-eared owls nest on the ground. They leave at 2 weeks of age, roughly. Snowy owls nest on the ground. They leave at 3 weeks of age. Great-horned owls nest up in a tree. They don't leave until they're 5 or 6 weeks of age off the nest here. So what's going on? So we thought, okay, how can we figure this out? There's some kind of stressful stimulus going on in the nest. Big brothers beating up on little, sibs and vice versa and all that stuff. So that was a question. So just before they're leaving the nest, this is what they do. They live in that nest, and then they're like, it's time to go. All right, and they all leave about the same age. So they're all banded before they leave the nest, so we can keep an eye on them. And we know each individual. All right, and then they just kind of get out there, and what they do, they're kids. What do? They scream for food, right? and that's what they do. So we monitor them, we chase them around. So getting to that question there, why do they leave the nest? So a friend of mine's an endocrinologist at Tufts, and we were chatting about it, and he said, we can do that. We can measure that, Denver. So if as he tells me and what we did, is if we can get in there and we can grab those chicks and take blood within 3 minutes, we're making the assumption that when we grab them, that's a stressful stimulus, okay? And it's a reasonable assumption. All right, but if we can grab and breed them and bleed them within 3 minutes, then we can get the basal level of corticosterone, the stress hormone, the fight or flight response, all right? Even though there's an instantaneous response to fight or flight, it still takes 3 to 5 minutes to register in the blood. And so if we can get it, we can get a measure. So here we are, this is Ann, and we're grab these chicks out of the nest and bleeding them. And then if you look here, just live with me for a second. So these are the ones in the nest, the dark ones, and these are the ones out of the nest. Okay? They both have pretty much about the same level. No mathematical difference between them here, but a mathematical difference over 30 minutes of bleeding. All right, so their basal level and their stress level. All right, this here makes sense to us. This here we're a little not too sure about the difference, the mathematical difference between these two. But as we kind of learned more about it, we just felt that it was a developmental process, that they could mount a response, but it wasn't really the strongest response until they got older. All right, and then, there's a bunch of stuff in here, but here it is right here. All right, we believe that predation. So what we think that when they leave the nest at 3 weeks of age, it's not that the big sibs beating up on the little sibs, because we don't see that in the owls. They're a much more advanced group than the birds, diurnal birds of prey that beat up on each other. And but we think it's probably predation. So they're growing as fast as they possibly can to get out of that nest, because there's things like raccoons, or maybe there's great horned owls or other things that might climb into the nest. And then if you start looking at short-eared owls that leave the nest at 2 weeks of age, they nest on the ground. They got to grow as fast as they possibly can to get out before raccoons and skunks and coyotes and foxes discover their nest. Then if you look at something like a snowy owl that nests on the ground, it doesn't leave its nest until it's 3 weeks of age, but it's really a big owl, so it probably has some developmental constraints and when it can leave. And also, its parents are big and powerful and very protective. It can drive most things off. And a great horned owl stays in the nest because it's just so big. It's up in a tree. Its parents can drive anything off. It's got no worries, and they stay in 4 or 5 weeks. So we think predation is the driving force behind that. All right, so they're kind of cool. You know, it's like, hey, hang out, got nothing to do, eat lemmings and voles and things of that sort. And this is one of our cams, and we work with Explore, the Annenberg Foundation out of California for many, many years now. And this is one of our cameras on one of our nest areas. These are 5 chicks. There were 6 in that nest. Haley, 6 in that nest, right? Yeah. Okay. And so these are 5 chicks just hanging out, doing owl-type things in the daytime, you know, just waiting for their folks to bring them something to eat. And so anyway, that's what they do until they can fly. The next question. So it just keeps coming, and it keeps coming. So is winter non-breeding or spring breeding season more stressful? All right, so same thing here. We go back to the winter roost sites, all right? Now, we probably have some, what do you call it? You got snowbirds when they go away in the wintertime, right? You know, why do you leave Montana in the winter? Well, it's cold, all right? It's a little stressful. I don't, you know, I mean, it's, you know, all that stuff. I'd rather go to Arizona. Well, these guys, I don't know if they're thinking the same thing as you, but here they are, eking it out in the wintertime. So you would say, huh, I wonder how stressed they are. Maybe they're stressed out. Maybe they're not. So we catch these birds in the winter, flush them, catch them, bleed them within 3 minutes. Same process I told you about a minute ago. Then we go to the breeding season, flush them, catch them, bleed them within 3 minutes. And we look down here. So this is the breeding season. This is the winter. This is your basal stress levels. All right? Highly significant difference between these two. Twice as high when you're breeding than when you're wintering. So it was just opposite of what you would think. And if you really think about that, those of you who are parents, I mean, raising a family is maybe more stressful than going to Arizona in the wintertime, you know? So that's what we conclude on that one. And you can, there's all the math, but this suggests that breeding, raising a family is more stressful than hanging out, having drinks down at, where did we go today? Durham's tonight? Okay. All right, so what about research? You know, we have licenses to harass wildlife, okay? And that's part of what we do. And we hope we do it for good reasons. And so we try to measure our impact on that. All right, so it's the same thing. Find the birds, flush them, get them in a net or whatever, catch them here, and then look at this. And you can see time between flushing and the court levels is all over the place. There's a negative relationship here. And so what it means is flushing might be a big pain in the butt, but it's not a stressful event. Handling, however, is stressful. So when we capture them, and they probably get flushed from time to time by who knows what, you know, deer walking through the gully or something like that, you know. But, so that's not such a big pain. No, not stressful. It might be a pain in the butt to them. But handling is definitely a stressful event. So local populations are doing around here and all that stuff. And so, you know, as I said earlier, it's one thing to go count nests. It's one thing to do a survey in the forest and say, oh, we heard owls everywhere, therefore they're doing okay. Well, that's pretty basic, and that's not really, you know, you don't want to end it there because you don't know. You need to find out, well, did they reproduce? Were they successful? How many were successful? And we kind of use the word success to indicate everything's good, but that's not really success. Success is only if your children reproduce. All right, so if you raise a family and they all die, end of the line. All right, so you need your kids to reproduce in order to be successful from a fitness point of view. So anyway, we do the same things and monitor, try to know males from females, you know, this and that. Now, this is 87 of 23 here. And so I try to make this point, particularly to my young people over here. If you were to study these things, let's just say right here, 3 years, you'd say, hey, wow, I got a decent sample size. Looks like the owls are doing great. And I can get a couple papers published. If you were to study them over here, you might say, wow, there's no owls anywhere. You know, what the heck's going on? But if you were to study them here, you would say, oh, populations fluctuate. So when you say they're fine here, and then all of a sudden you say, oh, we got to list them as threatened here. Well, if you kept studying, you would say it went up again, it went down again, it went up again, it went down again. That's the value of the long-term research, is sticking in there with it. I was on a plane, I don't know where the hell I was going. I think I was going to Japan. And this guy from Singapore was sitting next to me. And he was looking at, I had a graph in front of me, or doing something. And he looked and he says, well, that's an interesting graph. What is that about? And I said, oh, yeah, it's my research, you know. It's like a big deal, right? And he says, well, I'm an economist. And I had like 20 years of data or something, 25 years of data, whatever it was. He said, you know, he said, you might be onto something. He said, but I'd like to see you get like 20 more years of data in there, because then you can really tell a story. He said, because when we look at the economy, we look at the long-term trends to see how things go. Anyway, it was just interesting. He said, get back to work, is what he said. All right. Okay, then things like, is there breeding site fidelity? So think about those owls in the nest that I've showed you the pictures of, and then, you know, all the owls in those communal roosts. Every year, there's owls in those communal roosts on the same branches. Almost every year, those same nests can be occupied. Well, they got to be the same individuals, right? Right? But now we've banded so many of them. Again, long story short here, it's really uncommon for them to be the same individuals. The same branches can be selected for. The same roost, 10 birds in there, next year you come back and there's 10 birds and none of them are marked, but they're in the exact same areas here. So anyway, this is just, you know, a little bit of information, but I'll give you a better summary of it here soon. That's, hey you guys, that's Sophie Heinmarch. She's the barn owl researcher from Vancouver. Good researcher, all right. All right, and so, that's still a boyish person. So we find out that though it turns over every year, 90% of it turns over every year. And then we look at the mate fidelity. And so if we look at all these adults that we've banded, where we know the males and we know the females, only one pair, this is based on abandonment. We also have genetic data we haven't got to yet, but only one pair ever. So 280 nests, 2,000 birds marked in our study, and only one time have the male and the female come back in the same year and bred together again in the same nest. You know, I mean, it might have happened more often, but the point is, with the sample size that we have, it's pretty uncommon for them to do that. The population just turns over almost every year. But if anyone is going to show site fidelity, it's the male. All right? So the male will come back to the area. We have some small samples of that. Let me see if I've gotten to that yet. No, but all right, so here you go. Here's the female. 3 consecutive years within 25 meters of each nest. Really rare for females, but each year she had a different male. And then there's 10 males that nested in 2 consecutive years. Each year they were in the same area, but they had a different mate. And then we have divorce, remarry. And, you know, there's a lot of reasons for divorce. It could be the economics of voles. Maybe there's not enough voles. Or whatever, but, or, you know, I don't know what it is. But anyway, but even when they divorced, they were successful as a couple, raising their children. They divorced. Next year, they had new mates, and they were successful with their new mates. And their 11-month-old son was successful with some other girl, you know. So these are the things that we can get through the mark recapture. This is just a cool shot of an angry owl. All right, is there natal philopatry? So defining natal philopatry, you know, do your children return to the natal area, you know, and live, you know, whatever, forever and all that stuff there. So it's the same thing here. We've banded 767 nestlings. Only 28 have ever come back to their natal site to breed within the general vicinity of their natal site, you know. And so that tells you that 739 are never seen again. So, and then if they do come back again, it tends to be the male. Every once in a while, it's the female. How about dispersal? Well, going back to that, likely, if 96% of all the birds that we mark as nestlings are never seen again, it's unlikely that they die, that they all die. Some die, but it's unlikely they're all dead. And what we've learned, it's opposite males, but birds. Males are the philopatric sex. Males are the ones that are going to show natal philopatry, with exception. Females are the dispersers. So we think that males are trying to stay on good territories. Females are going around. They're going to mate who's ever the best mate at that time and not show any kind of long-term fidelity to a mate or an area. All right, are they family groups? Getting back to the original question, no. And, as you've probably seen now from the data there. So this is one of our cams again. Every year it's occupied. Every year the birds are in there, and 9 out of 10, 90% of the birds, 99% of the birds every year are different birds, but they use the exact same roost and oftentimes the exact same branches. So they're kind of hardwired probably genetically for specific habitats, and they drop into that, and then they have micro habitat selections. All right, so then you ask these questions. Okay, why is he there, and why is this one here? Are these guys, are they male and a female? And this is an outcast? Is this a dominant male? He doesn't want to hang out with two young ones? These are some of the things we're trying to get to. Are these guys friends? Friends. Friends always turn into something else. And so those are the types of questions that we're trying to ask, all right? Let's see. So my communal roosting. So no, it's uncommon to ever be there. We've never had adults winter with their offspring. We've only twice ever had two young birds stay in the same area at the same time. And then only very rarely were in the same roost. So they just up and leave. The entire population pretty much up and leaves every year, and new ones come in. All right, so this is what we're going to try to figure out here next time is we kind of experimented a little bit this year, but, does this male, you see him, where the heck is he? He's back in here somewhere, all right? Is that a dominant one that sits way back out in the vegetation where nothing is going to prey on him? Where these guys here, are these younger? Are they subordinates or whatever? They're on the lower branches. They may be more exposed to predation. Is it sex-related, age-related? What is it? So we're kind of trying to figure that out. Of course, we didn't have the big roost this year, and one of the things we figured out we could do is we could color their tufts. They have those tufts, it's a little white, and we did it with breeding ones this year, and we put a little color on it, and we could tell individuals. So that's the next thing. You need a lot of fingernail polish for that, though. All right. Fidelity is done in roost. Where am I at here? Okay. Yeah, the only thing, here's just the numbers. So we break it down into, you spend the winter, you winter, then you breed, then you winter, or you breed in your winter. And again, you can just see that it's just very, very low. Only 67% of 2 or more winters, and then they're just gone again. High turnover at the same site. Some questions. This is what I was saying. Do the same individuals use the same roost? Do dominant individuals root deeper within the cover behind the others to avoid predation or harassment? Is it age or sex related? Do potential mates or friends, see, roost close together? He's just my friend. All right. And so here they are again, and this is again what we're trying to tease apart. Here is the white on the feathers on the tufts, where we were able to color them this year. We had like fluorescent green from orange and whatever blue and something else, and we were able to know exactly which individuals they were. It was kind of cool. And most people couldn't even see them. So what do they eat? So this 41,900 prey we've recorded there, we quit doing it. They eat pretty much voles. So all the farmers and ranchers love it. They're like, God, I wish we had more owls on my property if that's what they're eating, voles and pocket gophers and things of that sort. Population estimates. This is kind of interesting here. This is just a pet peeve of mine. So, there's all these population estimates put out by all these, supposedly recognized groups. And so in one year they come out and they say there's 9,000 in Canada, 6,000 in the U.S., 15,000 in North America. A little later they come out with 140,000. And then in this year they come out with, 150,000. They break it down like that. They have no idea. And I'm like, who comes up with this stuff, And And it is, I hate to say it, I'm sorry if I'm offending anyone, it's a bunch of mathematicians sitting in an office, never going outside, not doing surveys, coming up with this stuff. All right, so cool picture, education program. So finally, as Jim was talking about, we cover it all. I think that's the one neat thing about what we do is that we're able to publish a children's book, get an award-winning scientific paper, give a talk to you guys, and cover it all instead of just being, totally so research-focused that you forget everything else. And this gives you an idea. Kyla Jarvis here, third grade teacher. She was a bartender. No, she was a waitress at the Depot in Missoula, where I met her, because we were always in the bars after work, right? So, and one thing led to another. She'd teach, will you come to my class and do a talk on owls? I said, no. I said, I'm not talking to kids. And so anyway, she forced me to come. And I went, and what ended up, the kids were really, she had them on top of it. And we provided the scientific information, and she wrote the first children's book, Owls Who Are They, which was endorsed by all the national parks and all that. And it's out of print now, Mount Press. So anyway, that's that, And then, high school classes, the high school science classes. And every time we take the kids in the field, doesn't matter what age, it's like the best class they had all semester, all whatever they were doing. And this just kind of shows it here. The University of Montana, both graduate and undergraduate students coming in the field. Instead of sitting in the lab, instead of sitting behind a cubicle, I can actually go out in the field, participate in field biology, and see what real life field biology is about. And then maybe you're in this one with your daughter. This is like an Audubon group. There must have been 60 people that day. There were so many cars parked on a back country road that the police came out and were like trying to towing cars and stuff like that, And so what we try to do is get people involved, as well. So covering everything, not just pure research, but also sharing it and all that stuff. And this is cool. So we're going to end it, as I said earlier, and I've done this out of the professional meetings, end it with some cool stuff. So this is a male. His nest is over here, not too far, over in that corner. All right, this is where he roosts. The live cameras give us some pretty cool access to things that we would never see. I've been working on owls almost my entire life, and I'm learning stuff all the time. But this was kind of cool. He's sleeping and something rouses. Let me see if this will work. Gina, let's hope this works. He sees something. Cooper's hawk. Watch the owl all the way. Now watch him decompress. He's doing his threat display. Support Owl Research Institute, you guys. We need the help. I'll take any questions. I got a little lost in a couple of slides. I couldn't read them. So, Jim, should I field a question or two, or just? Yes, ma'am.
When you ban them, is there any kind of tracking device, or do you just look at numbers?
Yeah, when we ban them, is there any kind of, we know the banning is just pretty straightforward, but there's other tracking devices that you can use. We put the first satellite transmitter on an owl in the world in 1999 up in Barrow, snowy owls. We put 6 satellite transmitters on them and tracked them to Russia and all that. And it was really cool for us. We learned a lot of neat stuff about it. So there's that. There's other technologies that people use, the GSM technologies, and then the MODIS thing. So there's different ways to track individuals. And it really gives you a neat insight into their actual movements versus banding. Banded here, it gets killed there, straight line. But with some of these tracking technologies, you can see all this. They went here, they went there. So that's where it's super helpful. Where it's more questionable for me anyways, when people start making inferences. Oh, now it's winking at a female, or, now it's doing this and that. I go, wait a minute, it's on a computer screen. So it gives you certain advantages to some things, and other things it's, so it's a step too far. Yes, sir.
How old does an owl get?
How old does an owl get? The general rule is, that I learned when we were in school was always, the bigger birds live longer than the smaller birds. I think we're starting to see there's definitely exceptions to that. So the long-eared owls, the oldest one we've caught was in its 7th or 8th year here in this study. But I know people who have caught great horned owls that are 20 plus years. You know, this is wild. Captivity, it's a lot longer. There's a guy in Massachusetts who caught a snowy owl. He banned it as a young bird, and he caught it 24 years later. Never saw it again. Caught it 24 years later. There's a guy up in Saskatchewan, I think it was. He caught a bird that he didn't know, a snowy owl, how old it was, but it was greater than one, and he caught it 20 years later. So certain individuals can live a long time, particularly in captivity. Yes?
Where was the picture of the 6 or 8 or 10 owls roosting? Where was that taken?
Where was the picture of the owls roosting? No Tellum Creek? Montana. Okay. I can't tell you. Yes, sir.
So when they're mature, you know, the Predation's obvious with the little ones. Who are they prey of when they're mature?
When they're mature,
Who's eating them?
who's eating them? Something like a long-eared owl. As adults, great horned owls will eat them. Barred owls will eat them. Cooper's hawks will kill them. You know, so larger birds of prey will kill them. But when you're the size of a snowy owl, a great horned owl, it's only the largest eagles that can probably take you down from an avian standpoint. From a mammalian standpoint, you know, we see things from porcupines that eat eggs in the nest, to raccoons that climb in the nest and chew chicks up but don't even eat them, to chicks just disappear, to poisoning and things of that sort. So, but the smaller owls definitely have to watch out for the larger owls and or the larger owls in particular. But at the same time, this is kind of neat. So I was out, was it last night or the night before? Last night, and I had a big owl, small, medium-sized owl, and a small owl, all calling. So people say that when the big owls are hooting, the great horned owl, and then the long-eared owl is over here, and the saw-whet was over here. Although you may be susceptible to predation by scale of large to small, you're not going to breed unless you're hooting and tooting. And so you got to get, so it's got to be strategic, you know, and all that stuff. So when people say that the little ones don't call if the big ones are calling, that doesn't work. So I'll hang out here and chat more with you, but, you know, take the newsletter. We could use like four-wheelers, trucks, snowmobiles, a house and barrow. There's a whole lot that you can support. Thank you again.